Welcome back to this lecture on alternating current charging or AC charging of electric vehicles. In this lecture we are going to learn about four things. First, what are key parts of an EV AC charger? Second, how does AC charging work? Third, what are types of connectors used for AC charging? Let us first look at the parts of AC charger. Cars have standardized vehicle inlet, and charging cable is used for connecting the vehicle connector to the infrastructure socket of AC charging station. In some cases, the charging cable is permanently connected to the charging station as well, similar to petrol pump. For safe and reliable charging process, there should be several essential components in AC charging station. Let's look at it by following the power flow from charger to the EV. When the charging station and the EV are first connected, the charge controller in the station communicates with the EV. In this communication, information regarding the connectivity, fault condition, and current limits are exchanged between the charger and the EV. Safety interlocks are used to ensure safe charging process and to stop the charging in the event of fault condition or improper connection between the EV and the charger. When the AC power is provided to the EV, the onboard charger has a rectifier that converts the AC power to DC power. Then the power control unit appropriately adjusts the voltage and the current of DC-DC converter to control the charging power delivered to the battery. The power control unit in turn gets input from the battery management system or the BMS for controlling the battery charging. The BMS monitors the key battery operation parameters like voltage, current, and temperature. It then provides input to the power control unit to control the charging power delivered by the DC-DC converter. Apart from that, there is a protection circuit inside the onboard charger. The BMS triggers the protection circuits if the battery's operation limits like the voltage or current are exceeded, thereby isolating the battery if needed for its safe operation. Now, with the basic understanding of the DC charging process, let us now look at four main types of AC charging connectors which are used around the world. The EV industry has unfortunately not agreed on one specific AC connector, so depending on the car brand and country, the connector varies in shape and size and pin configuration. One of the main reasons is the difference in AC voltage and frequency around the world. For example, in the US, power supplied using 120 volt 60 Hz single phase AC or 240 volt 60 Hz dual phase AC. On the other hand, in Europe, 230 volt 50 Hz single phase AC or 400 volt 50 Hz 3 phase AC is used. Due to these differences in voltage, number of phases and frequency, it leads to differences in chargers between the two regions. Generally, an AC connector has two or more larger pins to transmit power and a few more smaller pins for the sake of communication. There are four types of AC connectors used worldwide, namely the Type 1 connector, which is mostly used in US and Japan, the Type 2 connector, which is mostly used in Europe, including those of Tesla cars, the Type 3 connector used in Europe but being increasingly phased out by the Type 2 connectors, and finally the proprietary connector used by Tesla for its cars in the US. Besides this, China has its own standard for AC charging, which is similar to the Type 2 connectors. Now let us look at how these connectors are different by diving into the details. In this picture, we can see the Type 1 vehicle connector, which is used specifically for charging with single-phase AC. It has a round housing consisting of 5 pins. There are 2 pins, L1 and L2 for single-phase AC, 1 pin for protective earth, and there are 2 signal pins, which are used for communication, which is the proximity pilot (PP) and control pilot (CP). The proximity pilot is used for ensuring connectivity between the EV and the charger, and the control pilot is used for controlling the charging current. The maximum power and current rating for this charger for Type 1 are 120 volt or 240 volt single phase AC with a maximum current rating of 80 ampere. Let us look at the Type 2 vehicle connector, which is also commonly referred to as the Minikus connector. The Type 2 connector, which is used all over Europe, is circular in shape with a flat top edge. The top row consists of two small pins for communication, as we've seen earlier, namely the proximity pilot and the control pilot. The middle and lower row consists of 5 pins for AC power transfer. There are 3 pins used for the 3-phase AC connection: phase A, phase B, and phase C. And there are 2 pins which are used for the neutral and the protective earth. The maximum voltage current ratings are single phase 230 volt up to 80 amp, and in case of 3-phase the voltage is 400 volt and the current can be up to 63 amp. In case of Tesla, they use a proprietary connector in the US, as shown in this picture. In Europe, Tesla cars use the Type 2 connector for charging the cars. Unlike other cars manufacturers, Tesla is unique at its use the same connector for both AC and DC charging. With this US Tesla connector, a maximum charging power 17.2 kilowatt can be delivered to the car from the 240 volt AC outlet. You might have noticed that, as I have mentioned, the Type 1 and Type 2 connectors have 2 common communication pins: the control pilot CP and the proximity pilot PP. Let us look deeper into their function. The proximity pilot PP checks if the vehicle connector is connected properly to the vehicle inlet, the connection. If the connection is not properly established, the proximity pilot will detect it and the entire charging process will be disabled for safety. In case of the control pilot CP, the control pilot is used for controlling the charging current. The control pilot continuously sends pulse width modulated or PWM signals to the car. In this way, it tells the car the maximum current that can be drawn from the charging station, Imax. The car uses this PWM signal and then draws the desired current, IEC, and it ensures that as long as this value is smaller than the maximum charging current, Imax. To wrap up, you have now got the idea about the parts of an AC charger and the 4 AC charger connector types. We also looked at the role of the proximity and control pilot in the control and the protection of the charging process.